So now I want to take a look at the second type of combinatorics and statistics known as permutations, okay? So what is permutation? Permutation is the arrangement of an object or a finite object in a specific order, okay? For example, if there are three different books, A, B, and C, available to be arranged in a shelf, this can be done in the following ways, okay? So we can have the first position to be A, the second position to be B, and the last position to be C. We can also have the arrangement in this form. The first position can be A, the second position can be C, and the last position can be B. We can also have it in this form, in this form, in this form, and this form. So these are the total number of ways we can arrange the three books in a shelf, okay? If we are to arrange it and picking three at a time, all right? Now, if you are to assign numbers to these value labels here, let's assign 1 to A, 2 to B, and 3 to C. This will be 1, 2, 3, okay? Now, if you have this, this will be 1, 3, 2. So this is totally different from this, okay? So once you assign or you assume some values to these labels, you realize that arrangement is totally different, even though you see it to be A, B, C, okay? All right, but the question is this the appropriate way to basically do permutations? Is this the appropriate way to arrange, let's say, three books in a shelf? Let's say, what if you have 5 books, 100 books, 500 books, or 1,000 books? Are you also going to try to list it in this form? This will be very tedious, okay? So there's a better way to actually do permutation instead of actually trying to, this is actually good if you want to see the possible combinations or the possible options that you can actually do the arrangement. But if the number, the object is very large, this may be very tedious, okay? So in general, n distinct objects can be arranged using factorial, okay? N exclamation is read as n factorial, which is expressed in this form, okay? So like if you have to take the three different books, the three different books can be arranged in three factorial ways, which is 3 multiplied by 2 multiplied by 1, which is 6 ways. It's similar to this. This one is 1, 2, 3, 5, 6. So this is the number of ways we can arrange three books in a shelf, picking three at a time, okay? And if you have to use this approach, the factorial approach, you also get the same result, okay? All right, so now let's take a look at the general theorem for permutation. So the arrangement of n object in a specific order using r objects at a time is called the permutation of n different objects taking r at a time. And this is expressed below, okay? So this is the arrangement of n different objects taking r at a time, which is similar to n factorial divided by n minus r factorial, where n is greater than r, okay? So if you have to use this theorem on our previous example, you realize that the arrangement of three different books picking three at a time will be equal to 3 factorial divided by 3 minus 3 factorial, which is going here will be 0 factorial, which is 1. So we have 3 factorial in the numerator, which is similar to 6, okay? So let's take a general example for this theorem. So in how many ways can 9 people be seated on a bench if only 3 seats are available? So let's take a look at the solution. So the total number of ways we can have 9 people seated if there are only 3 seats available is n9 permutation 3, okay? So we want to arrange 9 people, picking 3 at a time, okay? So this is equal to n9 factorial divided by 9 minus 3 factorial. And this is similar to 9 factorial divided by 6 factorial, which can also be expressed in this form, okay? So yeah, 6 factorial can divide 6 out. So we have 9 multiplied by 8 multiplied by 7. So in the end, we are going to have 504. So the total number of ways in which 9 people can be seated on a bench if there are only 3 seats available will be 504 ways, okay? All right, so this is a trial question. I'm going to leave the solution in the description of this video so you can check it out. Please, if you find value in today's tutorial video, don't forget to subscribe if you have not. And thank you for watching.